Perfect. So welcome everybody to today's webinar. My name is Krystle Hastings and I will be your host. This is actually our first community building webinar of the year, and really excited to welcome Kerryn Gammie, who's going to be talking about the algorithmic lens. And we had to say that a few times to make sure that we pronounced it correctly. It's quite a mouthful. So Kerryn Gammie is a data scientist in AI for the Absa group. She's spoken for us a few times before. And one thing that Kerryn does really well is animated presentations. Definitely an incredible skill. So really looking forward to the talk. And before we get started, I'd just like to take you through the agenda for today. So I'm going to do a quick introduction, and that will be done through a video this year. So, and that will tell you all about who we are and why we have these webinars. Then I'm going to hand over to Kerryn so she can start her talk. And then we'll save some time at the end for questions and answers. So during the talk, please pop your questions into the Q&A at the bottom, and then we'll address all of those at the end. And I'll also launch some polls while Kerryn is talking and share the results with you live on the screen. So here is our introduction video. So I hope you enjoyed that video, just telling you about why we host the webinars, and that is brought to you by FinChatbot and French Tech. And if you would like to get in touch with us, you can visit our website, or you can stalk us on LinkedIn, and we'll get back to you as soon as we can. And that is me. So I would like to hand over to Kerryn.
Cool. Hi, hello. Thank you for the introduction. Yes, as Krystle said, I'm going to be exploring this thing of, I guess, fairness through an algorithmic lens. So let me get started by sharing my screen. Okay. Are you seeing that? Okay, vibes. Cool. All right, dope. So yeah, I will start if this machine decides not to freeze. Cool. All right, so cool. Hello world. I'm Kerryn. As I like to call myself, I'm a humanities baby for life, which really just means that I really enjoy the social sciences and think that they're incredibly important. So I'm here because I enjoy learning, and I also really love PowerPoints, specifically PowerPoint animations, and sort of notice, as most people have, that like as the world's data grows, the propensity towards like AI and like scalable solutioning grows too. And so while that's cool, unfortunately, a lot of the thing that can happen is like this weird elitism. And so I think that ideas that are like powerful and exciting, but not exclusionary, are great, and especially ones that can be instantiated by stories. Vibes. So this is kind of what I'm going to cover. So it'll be like, what is it? So what does fairness mean? What does algorithmic fairness mean, et cetera, et cetera? How does it work? Why does it work that way? Story time in terms of like how these models work, some of the use cases, and then kind of resources if people are looking to explore this on their own. Okay, so I guess the first thing to bear in mind is sort of like the general guidelines that an AI practitioner is meant to follow, right? So it's this idea of like you explore your data, you clean or standardize the data, then you do your training and testing, and finally your prediction and evaluation, right? So you essentially start out as this little like proverbial Dora the Explorer. You get your kind of data analysis to tell you about the data itself, gives you this intuition and understanding of the problem that you're trying to solve. And then it kind of gives you this high level summary without any overlaid assumptions. From there, you want to move into this thing of cleaning and standardizing your data. And this kind of improves the general quality of it. Normalizing and standardizing just makes the modeling a lot more easier and efficient, and then tends to preserve sort of the variable significance. Then you get into this thing of like training and testing your data. And ideally what you want to do is you want to split it up into majority training and then minority into testing. And the idea behind this is that it enables your model to generalize. So you train on this big portion of data, so the model gets to see and learn it and whatnot, and then hopefully is able to generalize on the unseen data, which is this testing data. And then, yeah, essentially you do this kind of cross-validation thing, which is a revved up version of training and testing. And then finally, the idea behind it is you obviously want to know how effective your model is, and you want to understand, like, has your model memorized the data or has it actually learned it? And that's sort of why you want to test out of sample. And then there are various kind of like accuracy metrics or prediction metrics that you can report on. And it, yeah, essentially just tells you how well you've done. Then the thing that kind of happens at the end of this, and this is very much kind of the prioritization matrix, if you will, of how AI problems are, I guess, spec'd, right? But at the end of it, people are like, ooh, yes, inherited bias is not great because of social implications. Statistical bias, however, is dope, and we should leave that alone. And so I guess sort of this talk is really trying to emphasize the importance of bringing the ethical lens to the forefront of it. Before we get into the sexy modeling stuff, we should be thinking about the ethical implications of socio-technical solutioning. Cool. So I'm a philosophy student. That's sort of what I studied. And so just to kind of give you an idea as to sort of what this means in a philosophical sense when we talk about like fairness, and to understand the differing worldviews that are there, we have two major schools of thought when it comes to sort of how we want to think about algorithmic fairness. So the one says we're all equal, right? And I guess the assumption there is that everyone in a group or a population has similar abilities, especially if we're not able to observe them directly. And so if there's a task and there are people within that population that aren't performing at the same level, it has to be as a result of structural bias, and in which case you can't trust your observed data or just the data that you have, right? So that's the one view. The other view, the other view is this thing called what you see is what you get, right? And it says that basically your population is your population, and you can observe their abilities with respect to that task. So if there's a subset of that population that isn't performing as well as another subset, that's just how it is, right? There is no underlying structural issues, and please just trust your data, essentially. And so what this means when you want to think about like debiasing or bias mitigation tools is to try and understand like which camp you're in, right? And these are just a couple of examples of the techniques that you can use to debias if you wanted to. So I'll get into some of these later. Cool. So leading on from that, so if we wanted to imagine, there's this thing, right, called the construct space, and this is unobservable. You can't necessarily perceive it, and this has stuff to do with like people's thoughts, ideologies, structural biases, etc., etc. But obviously all plays an important role in the task at hand, right? And so that kind of gets mapped to the observed space, and this is where data lives. So whether that's image data, whether that's tabular data, it's data about the population with respect to the task that they're trying to perform, right? And the idea behind this is that that thing, the data that you observe, might not be representative of this unobservable space because of bias, etc., etc. And so from this observed data, you then sort of want to map it onto something, right? You want to action it. So you want to have this decisioning space. And this is typically something that happens as a result of an algorithm that you've built or implemented, whatever. And so yeah, so where the machine learning part of it comes in is getting a sophisticated, sexy learning algorithm to get you from the constructed space, that unobservable space, to the decisioning space. And so again, whoopsie, if you kind of wanted to map this onto those two worldviews with the world equal, the idea here is actually that, like, no, there's structural bias there, so you can't trust this observation. That structural bias from the observation to the decision space is discrimination, and then maybe between the unobservable and the decision, there's non-discrimination, but who knows, right? Then in the what you see is what you get view, just believe whatever your data tells you. And here, when they're talking about fair algorithms, this specifically relates to computational efficiency that may exist within the algorithm. And that's probably where bias could exist. Okay. Then, yeah, fairness in terms of, I guess, the definition that you decide to take on is going to be different. And so even within like this community, the AI and machine learning community, there are differing views on what algorithmic fairness can look like. And those things can be, they can overlap, they can be mutually exclusive. It's all really tricky. Then if you want to think about, like, you know, ethics in terms of moral philosophy, that thing really centers humans and people and what is good and right for people. Whereas if you want to think about business ethics, that thing centers businesses and what is good and right for businesses. And I think we've seen in recent times that business interests versus like human interests can be deeply antithetical and zero-sum game in that regard. So this is just to say that this shit is hard. It's really hard, off the cusp, like, hot damn. Cool. Then just some myths around like AI being this deeply rational agent and you should trust it. So this idea that this is a perfectly balanced thing and how it is how it should be. That's inherently incorrect, right? So bias can exist at 3 points essentially. So at the data process, at the data stage, so that's whether the data is fundamentally flawed, either from the sampling or the fact that, like, you know, the data is representative of a larger issue at hand. You know, there's bias that will exist there. In classifiers as well, so these like machine learning algorithms that we use, so in the in-process stage, and then finally post-process, so in the prediction stage. So this is typically if you don't have access to the raw data and or the learning algorithms that you have, and really you just have the results, and sort of, yeah, the fact that bias can exist in those things too. So it doesn't matter where the bias exists, whether it exists at one place or multiple, it just gets bigger and bigger as it traverses the various stages. And that's why it's it's tough when you're scaling a solution like this. I guess why this matters to human people. So I mean, like, surveillance is a really big thing. Privacy or lack thereof is a really big thing. And I remember having this conversation with someone who was like, yeah, but I don't really care if people are watching me through my like laptop because I'm not doing anything interesting. And it's like, yes, same, babes. I'm also the most uninteresting person in the world. But definitely, if I'm at Mug and Bean and there's a stranger staring at me doing something uninteresting, it still puts me on edge. So now I definitely don't want someone looking at me through my laptop while I'm watching TikToks. Like, that's, come now. I probably also shouldn't be watching TikToks because privacy. But anyway, that's a concern. In terms of like trying to predict who gets sentenced, there's racial bias that exists in that. Access to finance. Oopsie, sorry, this pop-up keeps coming up. Facial recognition is another big one. If you're part of like the queer community, you're disenfranchised off the bat. Hiring algorithms have proven to be, yeah, incredibly sexist. Stuff around like access to healthcare and I guess whose healthcare gets prioritized. Recommendation systems, yeah, they also just like tend to mine a whole lot of data that isn't necessarily useful. Stuff around the self-driving cars, and you have to do this like exceptionally convoluted trolley problem to figure out who you want to kill. Like, that is the most, I don't know, just wild idea that you get to gamify this process of, I don't know, Armageddon. Anyway, there's a lot of ageism as well, especially when you think of like, yeah, like the terms and conditions around like signing up to software and stuff. Like, people who are of a slightly older generation typically get disenfranchised by this. Then you get stuff like Cambridge Analytica, which low-key economic warfare is not cute or fun for anyone. And yeah, it talks about like the fact that people can very quickly be excluded. And that's the problem, is that AI has the propensity to scale systemic bias and oppression. And therefore it means that it decides who doesn't matter. And that's why we should care. Cool. In terms of like the fairness metrics and terms, so there are a bunch, and just over the last like couple of years of me trying to understand this, like there's always more and more, and so I try to kind of figure out the most useful pockets of wisdom that I've come across, and so that's kind of what I'm going to be sharing with you, but it's by no means an exhaustive list of what's out there. Okay, so cool. So what does model fairness mean? Or what does it mean for a model to be fair? And really it just means that the errors are distributed similarly across protected groups, right? Even though there are many ways to define it. And a protected group is really just something that is like sensitive. So that could be race, age, sex, gender. There's a bunch of things, but yeah, so those are protected groups. So you have this idea of group fairness, and this talks specifically to having statistical fairness across the whole population, right? Then you get this thing called individual fairness, which is similar. So you also want statistical fairness, but it's only for particular individuals within that group. And it kind of doesn't care what group they're a part of. It just says that certain individuals deserve to be prioritized in this thing. So under group fairness, and this is sort of the thing that I want to focus on, is this idea of, demographic parity. And it just says, you have this prediction, y hat, and that thing is independent of the protected attribute. So I'm going to call that P. Then you've got equality of odds, which really just says that your true positive and false positive rates are the same for each population, right? So the error type is going to be matched across them. And then lastly, we have this idea of equality of opportunity, which is very similar to equality of odds, except it focuses on the positive outcome, right? So yeah, just that each group in that population receives the same good outcome. And I'll illustrate more of this sort of as we go through. Okay, cool. So now what it means to deep bias an algorithm. So if you ever come across, I guess everyone is on LinkedIn, right? So if you ever come across like someone on LinkedIn, you don't remember when they added you, you don't know how they got your name or number, but it's fine. You've got them as a connection, and they're punting this thing about like explainable AI or this AI that like mitigates bias or whatever. It's important to understand the distinction between those things and what they mean, right? So we have this thing called explainable AI or explainability tools, interpretability tools, auditability tools, etc. Generally, they fall under the same kind of umbrella. And what they try to do is really just figure out how and why a model is discriminating against a protected class. If you wanted to take the ethics out of it, it really just says, okay, how does this model work? Why is it giving me these answers? So it's an attempt to kind of demystify the black boxiness of the black box algorithm. Then on the other hand, you get bias mitigation tools, and that's sort of what I'm going to focus on today. So this thing says, okay, cool, I know that there is discrimination happening, and I want to stop it at some point. And so whether that's at the data stage, the modeling stage, or the post-processing stage, I want to prevent this bias from, from being a thing. Cool. So I'm going to touch very briefly on explainability tools, just to kind of give you like a sense of what it's all about. But so at the heart of it, yeah, just demystify the black box, tell you kind of what's happening, why it's happening, right? And again, this can happen across 3 stages. So you get the pre-modeling stage, the explainable modeling stage, and then the post-modeling stage. And all 3 of these stages try to do the same thing, which is really just like, guys, what is happening? What are we saying? What does this mean? And this is really important in corporate structures. And this is typically how I've seen like AI ethics play out, is that, you'll do something. I work at a bank, right? So a lot of the work that I do or have done in the past is quite regulated, which means that unless you're able to explain to a regulator how and why you're doing this thing, or how and why your model is doing this thing, you're probably not going to get it past the line, and that's not going to be put into production. So explainability tools in this sense have less to do with like, are we treating customers fairly, even though that's, I think, built in, but more about like, can the regulator understand this thing? And so fundamentally how it works is it has this like KISS principle, right? Which is just keep it simple, silly. And so it's loosely how tools like LIME work. And so LIME stands for locally interpretable model agnostic explanations. So the idea of local versus global just means that if it's a local prediction, it's an individual prediction, like per row, per person, per whatever. Interpretable just means that it's human friendly. So it's not coming out in like ones and zeros. Humans are able to understand that. Usually it'll be in terms of like a graph or something like that. Then model agnostic means that it doesn't actually touch the algorithm itself. It leaves it as a black box, and that means that you can then use it across an array of algorithms. So it doesn't just have to be like logistic regression, it could be anything. And then explanations, yeah, I guess it's something that is understandable to humans again. Cool. So broadly, the way it works, and there are problems that exist with these things, but broadly, it sits like a really simple, often linear curve or model around the instance, right? So around this particular event that's happening, and that's the thing that then gets explained. It can then also like randomly perturb. So this is an idea in machine learning, which it just changes the instances. And then you use that black box algorithm to make predictions off of this changed perturbed data. And then it essentially will learn the patterns of that perturbed data set and kind of give you a sense of how the model is behaving. And so just by way of example, so you have this cool and sexy learning algorithm, and you get this really cool and sexy accuracy score of 87%. And you want to kind of understand like, well, what does that mean? And so here specifically, we're trying to discern whether or not people are going to earn above 50,000 or below 50,000, right? So I think it's an income data set, a census data set. And this is exactly what this LIME package does, is it picks out these key variables and tells you, for people who are earning more than 50,000, like what are the things that are actually coming out as strong predictors, right? So age is in this instance would be an example of something that is a protected class. I'm not too sure about marital status in all countries, but I know in South Africa that's considered a protected attribute. And then it would do the same for the inverse. So for people who are earning less than 50,000, like what are the things that are coming out? Yeah, so that's on that's on like tabular data. You can do the same sort of thing with like image data. So here, if you wanted to understand like why this learning algorithm thought that this picture was a frog, it's telling you in that little explanation box that tiny little head looks frog-like, and that's why I thought it was a frog. And so stuff like this was really helpful when, especially I guess when image processing was really picking up traction. Like there was this like famous problem set where it was like this algorithm was doing really well at predicting wolves in the snow or whatever, and it turns out it wasn't actually predicting the wolf or the dog, it was just predicting that there was snow. And so as soon as you change the background, it didn't know that it was looking at a wolf anymore. So yeah, so this is kind of how interpretability tools can be used and I guess are being used. Then, oops, okay, cool. Then on the deep biasing stuff. So this is now where we're going to get down and dirty. Okay, so at the heart of it, bias mitigation techniques just want to achieve a small value of discrimination while achieving a high level of accuracy. And if you've spent any time in like a machine learning forum or the hellfire that is Twitter, you'll often see people in this community fighting over this trade-off between like, yeah, having bias mitigated and then having accuracy remaining quite high. So you want to minimize the one while maximizing the other, and that thing can be a really, really difficult thing to do. And so if we wanted to put it in sort of, yeah, I guess like an equation format, you have this discrimination metric, and there are many of them. And really what you want to have is this idea of the probability of class 1, this protected attribute, getting a positive outcome minus the probability of class 2. Ooh, did I freeze? I think I froze. Okay, so I'll say that again. So probability of class 1, which is a protected class, getting a positive outcome, minus the probability of class 2, which is also the protected attribute, also getting a positive outcome. So if we wanted to explicate this further, what is the probability of men getting a job minus the probability of women getting a job? And you want this, yeah, so this is in a more kind of statistical rendering, but you want this thing to be sufficiently small. You want it to tend basically towards 0. And that little E or backwards 3 is yeah, a mathematical way of denoting something really small. Cool. So on the pre-processing technique, so this is at the data stage. So here you're wanting to change the training data that the algorithm is going to then learn on, right? So yeah, so literally like you will, I don't want to say manually because you don't go row by row and do that, but you'll have an algorithm that is kind of massaging your data and changing it fundamentally. And so essentially the way it works is it will rank the features, so it'll rank the columns, and then it'll change the labels with the instances that are close to this boundary, right? And so again, by way of example, so you see there's the smiley face and the sad face. So the smiley, the faces represent some protected attribute. The smiley face is the favorable attribute. So let's say this is men getting jobs, and the unhappy face is women not getting jobs, right? And so here we've got, and where you have the pluses, that's obviously like successes, right? So where people have gotten jobs. And then you've got the probability of acceptance on the x-axis at the bottom. And so there are these arbitrary, well, not arbitrary because I drew them in, but you have these lines, these decision boundary lines that separate, you know, the positive class from the positive outcome from the negative outcome. And you see that this is skewed for the protected attributes. And so what massaging will do in this instance is it will create a new boundary line, and any instance that falls right next to that boundary line will change. It'll flip the sign. So yeah, you can see for like, I'm going to call it men, but for the happy face, that the one that was positive is now negative, and similarly for the unhappy face, the one that was negative is now positive. And so yeah, that's one technique. There are obviously issues that come with all of these techniques, but there are issues that come with changing the features in your data set, in the sense that it can lead to, yeah, deterioration in accuracy scores, etc. There's no one hot, fast rule of like what mechanism you should use. It really does depend on the data, but this is one such example of a technique that can be used and is used. So yeah, so really just swaps the labels for instances that are close to this boundary, and this creates a more balanced sort of representation. Okay. Then we get into this idea of reweighing, which is also a pre-processing technique. So again, deals with the training data. And so the idea behind this is it assigns weights to the observations given some protected attribute, right? So why this is, I don't want to say better, but has marked improvements relative to the technique I showed before, is that it doesn't actually fundamentally change the training data. It just creates like a new field essentially with the weights in question, right? So if we go back to our same example, so here what's happening is, you know, we've still got, you know, the 5 and the 3 positive outcomes for the various classes. And what we're doing is, yeah, we're essentially just reweighting it, right? So the 3 little bubbles at the bottom now are a lot bigger, and the ones at the top are a little bit smaller. So they're reweighted in that sense, in a visual sense. And if we wanted to express this like probabilistically, this is how we would do it for the weights, right? So the weights will essentially say, what is the probability of my expected, what is the probability of my expected favored class getting a positive result over the probability of the actual result, and then you would just kind of, you know, do that iteratively across the classes. So don't focus too much on the stats. That's just if you are interested in a more formalized definition of it. So yeah, so again, you know, having these weights makes the data a little bit more nuanced and balanced for modeling purposes. Cool. And then if we go into the in-processing stuff, so this is when you actually want to deal with the classifier or the learning algorithm that you're working with. So this is really the only technique I'm properly familiar with, is this idea of adversarial deep biasing. And so if anyone's worked with GANs or knows anything about GANs, it works in a similar fashion. So yeah, so basically what it does is it builds 2 models, right? So you have model 1, and this predicts the outcome, right? Which is y hat. And let's say the outcome is whether or not someone gets a job. Then it builds model 2. Model 2 is known as an adversary. And what model 2 tries to do is it tries to predict the English. Yo, guys, English this week has really been tackling me to the ground and spitting in my face. It's been awful. Let me try that again. So what model 2, which we call an adversary, what it tries to do is it tries to predict the protected attribute. So for our example, let's say gender, given the predictions made from model 1, y hat, right? And so just to rephrase this, because I don't think this is the most intuitive idea unless you've built one of these models before. But so I have one model and it tells me, so I've got 10 features. One of those features happens to be gender, right? And so I use those features and it tells me whether or not someone is going to get this job. Then model 2 comes along, and using my predictions, it will essentially try and figure out this protected class. So it will figure out whether I'm using race, gender, age, etc., etc., etc. Cool. So the idea behind it is if no bias exists, then model 2, this adversary, won't be able to predict the protected attribute, right? So you're fine, you're Gucci. If, however, it does exist, which it always does, what model 2 does is then adds like modifications to model 1, and this is typically through parameters and weights and stuff like that to then disrupt the predictive power that model 2 has, such that it'll do this, it'll iterate through this until it can no longer predict the protected classes given the predicted outcome from model 1. That's pretty much how it works. Yeah, so model 1 again just predicts the outcome y hat based on x, which are your features, and then it sort of goes up against model 2, which is meant to predict the protected class given the predictions from model 1. And so a nice way to sort of understand this is to really look at the architecture of some of these things. So here we have a neural network, and I'm not going to get into anything too wild because those things can get wild very quickly. But basically, you can see here there's the model 1, which is the green thing. And so this is predicting the label. And then you've got the model 2, which is that red thing. And it's meant to predict those protected attributes, which in this case is sex and race. Right. And so if you have a look at this graph, so this is before any debiasing has been done, you can see that things aren't tending to that dotted line, which is where they should be, right? So these box and whisker plots are, yeah, they're pretty skewed. And so you can see the dark blue stuff represents, the favored class. So this is probably people who historically have occupied positions of power. And the light blue class is maybe people who have been like systemically disenfranchised and whatnot. So if you were to use this adversarial debiasing technique, it essentially gets you to a much more even and holistic and I guess nuanced view of what's actually going on without necessarily needing to compromise too much on accuracy. So that's how it works. And this is at an algorithmic level when we're talking about learning algorithms. Cool. Then if we have a look at sort of post-processing, so this is assuming that like, for whatever reason, you didn't have the data, you didn't have the learning algorithm, but you've got these results and things are just looking shaky. And you're like, nah, let's figure out what's going on. So there's this idea called equalize odds. And really what it does is it just checks whether this classifier predicts the label equally well for all values of that protected attribute, right? So essentially proportionally, I guess we always have to talk about proportions, but like proportionally, is there an equal rate of true positives as well as true negatives for each of the groups that are in these protected attributes? And then you've got this idea of equal opportunity, which is a similar thing. The only thing that's different is it focuses solely on the positive class. Cool. So what this technique does, if you use this equalized odds post-processing technique, is it will change the labels using some kind of optimization scheme to then enable fairer predictions. Cool. Then, at large, you've got this decision tree. I love these things because they're very much like Cosmo quizzes, but now it's like for adults, responsible adults. So instead of figuring out like which cocktail you are, you now get to figure out which debiasing technique to use, and that's fun. So this is really just as like a frame of reference to figure out like what it is that you're trying to do. and yeah, so I won't go through this iteratively because we've kind of gone through it in the previous slides, but yeah, this is always a really good point of reference, is to whether you're using a reference like this or whether you're creating your own. I think it's always good to kind of map out what it is what are your options that are available to you, and what exactly is the path that you're trying to follow, and how best can you get there. Cool. So now in terms of what AI practitioners can and should do. So yeah, establish a framework and a philosophy. And I was very specific about wanting to present on like the algorithmic side of things, because I think if you're leaning into the beauty of calculus or statistics or anything like that, it's a little bit easier in the sense that yeah, I think it's easier to know when you're going, when things are correct, right? Because maths can, not always, but it can be quite binary in that sense. Like, you know, if 1 + 1 = 2 is correct, and you know if it's wrong, right? So the philosophy and frameworking stuff is hella hard, and it's hella hard if you're doing it by yourself, and probably even more difficult if you're doing it in an environment that, you know, has other people, because people think different things, and yeah, they believe different things, and so that's really difficult. But I would say before you get onto like the algorithmic stuff, it's important to know, yeah, I guess what your principles are, what you think matters, who you think matters, and then I think it's a little bit easier to do the algorithmic stuff. Cool. Having said that, then contextualize your explainability and debiasing tools, right? So what I mean by that is, are you doing this for corporate? Are you doing this as part of a research institute? I guess, who is your audience in terms of like the people that you're trying to convince or get on your side? And then also, like, who exactly are your end users? Who are the ones that are potentially going to be affected by this, you know, adverse piece of tech? Because yeah, different metrics are important, but only in certain situations. So that's why it's important. And then, yeah, do your readings, especially your sociological readings. I think one thing that is taken for granted in, yeah, tech and STEM spaces is that, yeah, people are just smart and they don't have to do readings outside of their like disciplines, and that's inherently incorrect. There's a lot in the humanities and social sciences that is meant to aid the way that we do socio-technical solutioning or technical solutions for society. And so I think if you're in this space, the onus is on you to, yeah, to be reading up on like critical race theory or feminism or like, yeah, capitalism and its downfalls and how it can adversely affect people, et cetera, et cetera. And then, yeah, I guess just including people who are well versed in sociological lexicon, I guess, to get them on board and to get them to, yeah, to assist in that way. Cool. And then lastly, but yeah, super important, is to engage communities. And I mean this both in terms of like, you know, try and engage like the AI ethics community, but then also engage, I guess, like communities that you think are going to be either recipients or consumers of the technology that either you create or that will be created by AI practitioners. Cool. And so these are some of the frameworks that I've come across, and one of the ones, some of the ones that I think are really well researched and nuanced, and kind of do that balance of like having a really deeply philosophical ideology and then trying to make that thing pragmatic. And so I would strongly recommend going through, yeah, through this list of things. But kind of more broadly, what I've picked up on when I've done my research on, yeah, algorithmic frameworks that focus on ethics, is that there are kind of 4 really important things. So one is transparency, right? So I guess be honest about the tech, about who it might hurt. Yeah, be honest. And this is not just for people who are creators of the tech, but for people who are consumers of the tech. So this can and must be technical and non-technical. Then the second thing is really just, yeah, don't hurt people, right? Unintended harm sucks, but I guess on the balance of probability, a lot better than intended harm. So do your best not to hurt humans. Oh, and the environment, but yeah. And then in terms of like safety, so again, like if you recognize that there is a propensity for harm and hurt, make sure that you're doing the most that you can algorithmically to protect, to protect the protected classes, I guess. And then explainability, yeah, I think this is important as data scientists and also as people who are not data scientists. Like, it's just good to understand how your things are working, because otherwise it can lead to well-intentioned but irresponsibly created tech. And then sort of the last point on this is that all of this is really good and well. And so I'm speaking about it in the context of corporates, right? So where you have like a hierarchical structure, cross collaboration needs to happen. So it can't just happen in your tiny little AI team where everyone thinks that ethics are great and we need to prioritize it. But if it's not happening in the marketing team and the credit risk team and the whatever, it's sort of fails, right? And then having an external AI ethics unit or team that oversees either the creation of frameworks, the maintenance of frameworks, etc., is really, really important. I was speaking to someone the other day and he gave this really good analogy where it's like, as data scientists, if we are the producers of the tech, it makes no sense for us to be checking our own homework while creating the memo to check that homework, right? Like, you need to have someone that is external and somewhat impartial to also just check for biases that may happen. And then, yeah, making sure that if you've got 1 and 2 nailed down, that you have standardized and measurable metrics, right? So that it makes it easier, I guess, to compare pieces of tech across different use cases, essentially. Cool. So these are some of the explainability tools that, so some of them I've used personally, others I'm in the process of using. And yeah, I think all of them are really compelling. If you're a developer, so if you're really technical and you want to understand like how things are being built, these are really dope. But also if you're not technical and you don't develop algorithms in this way, they give a really nice sort of non-technical kind of understanding of how these things can be used, and I think that's helpful. Yeah, these are some more tools on explainability and bias mitigation. So all of these I've used, and yeah, they obviously all have their issues, but like, it's a good starting point. Cool. And then on just like doing your readings, right? So my fave, RuPaul, always tells us that reading is what? Fundamental. So yeah, do your readings, and I understand that it's difficult to do that thing, and especially trying to weed out like what's good and what's bad. Like, that thing is always really difficult, especially in the time of fake news. Personally, these are the sites and platforms that I've used and have really helped my learning when it comes to ethics and AI in general. So I'd strongly recommend that. And then, yeah, in terms of community, and this is specifically in terms of like having an AI community. So my personal faves are Twitter, the deep learning indabas, and meetups. I think you meet some really wonderful, wonderful people who have really wonderful skills and expertise. And yeah, if you can like do that thing, because it makes it a lot easier if there are other people who are trying to do the same work that you're doing, and can really just be the shoulder to cry on when your code isn't working, you've pushed git blame and git blame says you're the one at fault. It's helpful to have people in your corner. Yeah, so that is it from me. That's my talk. Yeah, I see there's like 15 or so minutes. So yeah, happy to take questions, comments, etc.
Thank you so much, Kerryn. That was super, super interesting and a lot to absorb. So thank you for sharing all of that with us. I think to start off quickly, we do have some really great questions from everyone who joined, but we did launch 2 polls during your talk. The first poll that we launched asked the question: a machine model is created that adversely affects a group of people. Who is responsible? And what was really interesting was that 90% of the audience said that everyone involved in the creation and production of the solution of the model is responsible.
That is the correct answer, yes.
Fantastic. So if you guys gave that answer, give yourself a tick. And the second question that you asked was, is it possible to create fair machines in an unfair system? And funny enough, we had an equal 38% saying yes and saying, is this a trick question?
See, that's the correct answer. It absolutely is a trick question.
Nice. Okay, perfect. So going to the audience, just in the chat, we've got some questions. I think starting with KU, she says, does it matter what kind of models? I remember reading Pearl talking about the Bayesian network model is by nature transparent and explainable. So does it matter what kind of models are used?
So maybe just a question on that question. So, okay, no. So if your model, I mean, if your data is biased and just not great, then it sort of doesn't matter what model you're using if you're not doing anything to debias the data or anything like that. And so maybe just a point on algorithms themselves being problematic. It's not necessarily the case that like an algorithm might be designed with like, I don't know, with bad intention, but what often happens is that algorithms can amplify the bad thing that already exists in the data. So I guess in that sense, yes, it matters what model you use, in the sense that some can amplify things and more so than others. But in terms of like, is the model that you're using more racist or more sexist than another one? Intrinsically, like, no, probably not. Like that's got to do with your data, but yeah, it can amplify those issues in the data set.
Great, thank you for that. And then Papa asked, so a question for the end. So there's also a risk, is there also a risk that massaging the data induces its own bias? And can we account for that secondary layer of potential bias outside of algorithm transparency and diverse review?
Okay, firstly, hi, hello, it's so nice to have you here. I love you and I miss you so much. Then on your question, yes, 100%. And definitely got bitten in the bum myself when trying to do this. And this is when I was a baby data scientist and I was just playing around on Kaggle and someone was like, oh, there's this thing that you can do. And I was like, oh my God, of course. This is the feminist agenda and I'm going to do all the things I can on this data set and it's going to be great. And long story short, it was not great. It created its own set of biases. And then it became that weird thing of now you're trying to reverse engineer the positive bias that you created, but then somewhere along the line, like you also get lost. And so yeah, definitely, yes, it can create its own bias. In terms of how you might be able to account for that second layer of potential bias outside of algorithm transparency and diverse review, like, yes, I guess, but there's always kind of going to be that, I don't know what the correct way of saying this is, but you can only kind of iterate so far. And so I think if what you're picking up early on is that massaging your data is giving you adverse effects, whether in terms of like propagating more bias across different protected classes or in terms of like deteriorating your accuracy, it's probably better to just throw that technique out of the window and explore something else. Yeah. So another thing that can also happen with like this massaging technique is sometimes people will actually just throw the protected class out of the data set entirely, and that doesn't help either. So yeah, so those are two kind of unfortunate outcomes that can that can happen.
Perfect. And then the last question from Papa is, are there times when punitive and assistive measures get blurry? For example, if a measure is assistive in that it attempts to provide people better healthcare, could it not also be unintentionally punitive if it does not provide the same assistance to certain groups?
Yes, yes, yes. Yeah, that is the long and short answer is yes. And I think this is also where like the frameworking stuff is just like so like itchy, like it makes your teeth itch at a molecular level. It really sucks because again, and I think I had it in one of the previous slides, but it's like, you know, fairness metrics or fairness understandings can exist in like a mutually exclusive way, but sometimes they can also be deeply antithetical to one another. And so if you wanted to prioritize one group's safety, it might necessarily mean precluding another group from being safe. And so I think like outside of algorithms, in a non-algorithmic, non-automated world, I think we struggle to understand intersectionality. And like, so if you are, so if you're Black and poor and a woman and queer, like, whoa, this world was just not set up for you to begin with. So now trying to get like an algorithm to try and solve those things, it really comes down to like, okay, cool, which of these disenfranchised parts of your identity hurt the most, right? So do we want to protect like poor people? Do we want to only protect women? And like, I guess, so to answer your question, yes, 100%. And that's why this stuff is hard, and either we bang our heads against the wall and cry, or I guess we just start doing the thing. Or I guess we can do both, right? Intermittently banging our heads against the wall while trying to do things better.
I guess I think what's really great is we do have an awareness of it. So at least there's people working on trying to remove some of the different biases from it, which is important. From an anonymous attendee, so you've obviously inspired somebody. They said, how do I start my AI and machine learning career?
Oh my God, hit me up, come through. No, but for reals, like hit me up. I'm on LinkedIn. I can drop my email address, whatever, hit me up. But honestly, the best thing that I can recommend, so because I came from a non-technical academic background, the thing that helped me the most was like learning how to learn, which is a simple yet non-trivial thing to know. And so I think once you figure out how you learn and absorb knowledge, it kind of makes all the other stuff easier. So when it comes to the coding, it's like, you know, if you're able to speak English or any other language, you have the propensity to then learn other languages, and coding is just that thing. So maybe the first thing that I would recommend is, I guess, figure out what it is that you want to do with AI and machine learning. Is it just, you know, do you just want to like flex on your friends? Do you want to build cool, sexy tech that, I don't know, predicts whatever it predicts? Are you really interested in like image stuff or tabular stuff or whatever? So I guess find out what your interests are, and then how AI can get you to that point. And then from there, I would say like the things that you need to learn. And I have no idea, Anonymous, if you're like from a technical background or not. So if you are from a technical background, I assume that these things are a little bit more intuitive, and so maybe it will come quicker to you. If you're not, just you'll be patient, and understand that like, the only L that you take in machine learning is a loss function. But in terms of, so I guess in terms of like the stuff that you can study and learn about, coding, so pick your language, whether that's R or Python or JavaScript, and then learn linear algebra hella well. That thing is everywhere. You can't get away from that thing, and it really will just beat you into submission. So just be ready. Maths as well, so like calculus I think is really helpful. Calculus is really helpful, and then stuff around statistics. So if you have a general kind of understanding and intuition of statistics, that makes all the other subsequent learnings a lot easier. And then in terms of applying that knowledge, so if you're not into courses, I would say get into competitions. So Kaggle and Zindi. So Zindi I would probably rate a lot higher, just because it deals with like a Pan-Africanist view of data collection and problem solving using African data. So that's a really nice way to learn and also meet people. And then, I guess come to more meetups, because you can learn really quickly in that way.
Fantastic, cool. So that's quite exciting. And then last question before we go is from KU, who says, hear the importance of data bias, but let me ask differently. How much is Bayesian network model used currently? I am puzzled with the black box claim because Bayesian dominates, then explainably shouldn't be a problem. And if Bayesian isn't used that much, what is the most used model, if there is any dominant model?
Sure. Yeah, look, good question. And I'm going to be honest, I've never used like a Bayesian network in like my professional stuff. So I've never built one from scratch and I don't know the intricacies of it. In terms of like the dominant model, so I guess it depends on like the problem statement that you're working on. So if you're doing like image processing or working with image detection, neural nets are probably going to be the most dominant thing. If you're working on tabular data, it's literally anything from, and I say this in jest because I don't think it's machine learning, but anything from a logistic regression to like SVMs to random forest classifiers to like KNNs, et cetera, et cetera. So I think it really depends on the problem statement that you're working on. And I suppose it's just in my line of work, like we haven't needed to use Bayesian networks that much, so I haven't come across it. In terms of the literature, in terms of the literature and the stuff that a lot of these debiasing and explainability tools are built off of, they're almost always some sort of permutation of a logistic regression, a random forest, and a neural network. So in that sense, I guess those are maybe the most dominant models that are used. But those again are only for like research and yeah, for research purposes. And so I don't know if that is different across like the various corporate stratospheres or other research groups. I'm probably not the best person to answer that, unfortunately, but happy to chat about it like offline if you want to get into more of the like Bayesian stuff.
Awesome. Thank you so much, Kerryn. Really appreciate your time. Always enjoy your presentations, and hope we can chat again and have another meetup. We do have a talk coming up this year with Pilenomy, who will go a little bit deeper into the AI ethics.
He's the best. Everyone needs to go to Pilonomy's talk. It's fantastic. It's my favorite talk in the whole world. Do it.
Absolutely. And I think even Pilenomy, I think she's with us. So hi, Pilenomy. I see that you are joining the talk today. So thanks for joining us and we look forward to your talk. And thank you everybody for joining us and supporting our community. And I hope to see you at the next talks and have a fantastic afternoon.
Cheers, everyone. Thank you.
Bye.